Welcome back. So today we're starting our final section, section 6. So in section 6, we're going to spend 2 days talking about rational equations. So this is kind of the bulk of what we're doing here. The bulk of what we want to get out of all of this is how can we use this knowledge in order to solve equations. All right, so one little caution for you is make sure when you get solutions, make sure it's not extraneous. Make sure that when you plug that solution back in, that it wouldn't be making you divide by 0, all right? That's going to be a key thing here. Now, there's 2 strategies that I'm going to go over today, all right? Strategy 1 is if you simply have 2 fractions set equal to each other, okay? So in both of these cases, you can see that that's all you've got. 2 fractions that are set equal. All you do is cross multiplication. All right, so cross over this equal sign to get 5 times x plus 2. Then set that equal to when you multiply 3 times the 2x minus 1. Okay? And again, I know you've seen this back in Expo and probably even previous. So now we're ready to simplify. We're going to distribute that 5x plus 10 equals 6x minus 3. I'm going to subtract 5x from both sides. So I have 10 equals x minus 3. Add the 3 over. You get x is 13. All right, what about our other one? Well, the other one, same thing. 2 fractions that equal to each other, just cross multiply. All right, so on this side, we get 7x plus 7. On this side, we get 4x minus 8. Subtract 3x from both sides, so I get, 4x from both sides. So I get 3x plus 7 equals negative 8. Subtract the 7 off. And now divide by 3. So I think you guys are usually really good with cross multiplication from what I've seen. Okay, so now let's take a look at our other strategy. Okay, so now we have some addition and subtraction going on. It's not as simple as just 2 fractions being set equal to each other, is it? So now we have to take some more extreme measures, all right? So for these, what I'm going to do is I'm going to find the least common denominator for each of these, okay? So for this first example, I have an x and a 5x in the denominator. So I think you can probably see the 5x already incorporates the x into that denominator. So the only thing I really need to worry about is getting 5x on the bottom everywhere. So what does that entail? Well, that means that this x needs a 5. The 5x is already whole. And then this needs both pieces, okay? So when you're solving equations where you're adding and subtracting fractions, this is what I need you to do. Find a common denominator for everything, okay? So I'm going to have 5 over 5x. Actually, I'm going to write this in black so that blue work stands out. So 5 over 5x equals 6 over 5x plus 5x over 5x. And now the cool thing is when I multiply both sides of the equation by that denominator, the denominator just nicely cancels off everywhere. Okay, so that's the cool thing about finding a common denominator is it makes it super simple later on because you end up with something like this, okay? Now you just multiply everything by 5x on both sides, and it's gone. Now I just have something linear to solve. So subtract 6, divide by 5, so x is going to end up just being negative 1/5. All right, so let's look at our next one. All right, so the next one, we have 6x squared, 2x, and 6x squared in the bottom. So I think you'll probably notice pretty quickly that the 6 already incorporates the 2, and the x squared already incorporates the x. So our common denominator, once again, is one of those pieces. The common denominator is just that 6x squared. Now we just have to fill in the gaps to make that 2x become the 6x squared. Well, what it's missing is 3x. Okay, so I'm going to multiply top and bottom by that one by 3x. So now it will be that common denominator. And again, the reason that I'm doing that is because now I can multiply both sides by the 6x squared, and it just cancels everything. So all I have is those numerators left. So now I subtract 7 from both sides, divide by 3, and I get my answer. All right, let's take a look at this one. So I see a 5r, a 5r. This needs to become a 5r. So I multiply top and bottom only on that one. So now I have the common denominator in every piece. And the power in that is now when I multiply by 5r, every piece in the denominator disappears. And all I'm left with is this. All right, so let's subtract r from both sides. Subtract 1. And finally divide by 4. So again, I really don't think it's that terrible. You just have to make sure you find the least common denominator and then multiply it away. When you multiply both sides by the least common denominator, then it all disappears. All right, so let's deal with our word problem really quickly, and then I will set you free. So you work in a pharmacy that mixes different concentrations of saline solutions for its customers. The pharmacy has a supply of two concentrations, 0.5% and 2%. The function y equals that big mess gives the concentration of the saline solution after adding x milliliters of the 0.5 solution to 100 milliliters of the 2%. How many milliliters of the 0.5% solution must you add for the combined solution to have concentration of 0.9%? All right, so we want the combined, and the combined is being represented by y. We want that combined concentration to be 0.9%, or in terms of a decimal, that would be 0.009, okay? We want to know how many of the other one, how many of the x solution is that going to take? So ultimately what we have is this equation. Now, I'm going to simplify this piece right away, just because that 100 times 0.02 That's just 2. Okay, so I'm just writing that a little bit simpler for us. But otherwise, really all I've done is put in that 0.009 for y, because that's the combined concentration that we want. All right, so now how can we solve this? Well, if this is over 1, really this just becomes a cross multiplication problem. So I have 0.009 times 100 plus x equals 1 times that 2 plus 0.005x. I think that's probably the easiest way to think of this. So now that you have it as a cross multiplication problem, all you have to do is finish simplifying. So let's distribute that. So 0.009 times 100 is 0.9 plus 0.009x. And then obviously multiplying by 1 doesn't change that one at all. All right, now, in terms of what's the easiest way to solve this now, I like positive things. So I'm going to subtract off the 0.005x. So I'm going to have 0.9 plus 0.004x. I wanted to keep that coefficient positive. And now I can just subtract off the 0.9. So 0.004x equals 2 minus 0.9 is going to be 1.1. Now, finally, to find x, what do? Well, we need to divide by that 0.004. So 1.1 divided by 0.004 is going to be 275 milliliters. That's how many milliliters we need to add in to get that concentration that we're looking for. All right, so again, this one, considering I gave you the equation, honestly isn't that bad. You just have to make sure that you can manipulate those fractions for me. All right, so again, thank you so much for joining me. Make sure that you have your all your notes written out nicely, write the summary for me, and then come back ready to do your practice work.